for anyone who's watching that might be interested in Ohio.gov's COVID-19 reporting data, I wanted to share a code that I made using RStudio that scrapes the Ohio.gov website, and I run this every day. It scrapes the Ohio.gov website for the CSV that they place on the website and update around 2 p.m. daily. For those of you who've never been to the website, you can click around coronavirus.ohio.gov and go to a dashboard where they report some data, and they use Tableau to populate some dynamic instances of cumulative data, and you can kind of get to daily data, but it's very hard. You have to scroll to the top of a bar to see the number of cases that were added in a particular day, and then you can scroll backwards to see that cumulative count and added illnesses or hospitalizations or deaths by day. For those of you that found that difficult, I'm writing a script that actually is just going to grab the CSV behind this link every day and save the CSV. And I've actually been doing this since May, where I've compiled, it was May 23rd that I began. I just started compiling all of the CSVs because I noticed death count by age was going down from one day to the next, even though it was a cumulative figure. And that didn't make sense to me, so I was trying to put a reason to when and where these deaths, hospitalizations, and cases were increasing and decreasing, and then across what human demographics, at least the demographics that we have in terms of age and gender, these metrics were increasing or decreasing. So I'm happy to step you through the code. I'm not sure that anyone is particularly interested in this. If you are and want this code, just let me know. There's a couple of changes you'll have to make in terms of saving the files. I'm obviously saving it to my own directory. And then I'm looking at, the wrong folder. This is the code that I'm using from coronavirus.ohio.gov. And the only thing that you really have to change is this file path. I made this file path that is specific to my computer, my user, my desktop. So you would probably need to change that if you're interested in ever running this code. But today is June 26th, and I'm going to select all. The last that I ran this code was yesterday, so it grabbed the CSV published on June 25th, and it will grab the 26th and actually compare the CSV that was available on the 26th to the CSV that was available the day before, so we can actually see really who, when, and where these three metrics increased, and in some cases somehow decreased from day to day in Ohio. So I'm going to run the code. It just is going through all of the steps. It does not take very long to run, and it creates a couple of data outputs that I like to look at. This first one I think is called change in age. Just taking you through how it works, it takes the age group 20 to 29, 30 to 39, etc., and it actually looks at the cases that were reported most recently, so I just call those yesterday cases because I imagine it's yesterday, June 25th, that most of the data is coming in for on this particular day. And then 2 days ago, so that would be the data that was available the day before on this most recent CSV -1. So right here is the June 26th CSV, there's the June 25th. So we take a look at it, age 20 to 29, cumulative, there were 7,834 cases in this age group most recently, and in the day before there were 7,592. I am not Mike DeWine. I will not make you do the math because I can just scroll over here and see that that is a change of 242 cases for this particular age group. And I've actually sorted, and you can sort within this our output. You can sort so that we're looking at descending case changes. So 242, 193, 140, 126 increase in cases, and that is in most of our younger demographics. So 20 to 29, absolutely, they are getting the greatest increase in cases, and that's been the case for many of the most recent days. However, let me look at this. Let's sort by death change. So this is just the difference in deaths from the most recent CSV to the penultimate CSV, the one from the day before. I'll sort decreasing. 8, 6, 2, 1, that's 14, 16, 17 new deaths, and this is my favorite, a negative death. I don't know, maybe that was an age group that was written down incorrectly and they got classified into another age, but I don't know how you have negative cumulative death change over time. maybe this person came back from the dead, but it's not the first time we've seen it. And this was I'm running this for the first time, or running this